pull request is basically a code review before merging something into the main branch. Here's how we use pull requests. My colleague created some feature, wrote a short description, added a screenshot. Sometimes we add GIFs. I looked at the code, I looked at the feature, so it looks good. But then there's another comment, and it says Jenkins build failed. So we run our continuous integration builds on all our pull requests, so we know if something broke before it gets to our main branch. And if you remember, this is how our revision history looked like before. It's a mess, and here's how it looks now. It's a lot cleaner, and other things improved as well. There's less random commits. It's just better.
Yeah, so now we are ready to deploy our master branch. We want to keep it stable all the time. But how do we make sure it's stable? We could keep an eye on our build server or make it send a lot of messages to those who break the build. But people are receiving too many emails anyway. So we thought of something better. There is this nice little chatbot by GitHub called Hubot. And we were playing around with it. It was sitting in our company chat, picking its nose until we found real good use for it. Notifying about build failures. So in this example, a brave developer made a small change without a pull request. But since karma is a bitch, the build failed. And it took only a few seconds to notice it in the chat, and a couple of minutes later, the build is back to stable. It's worth mentioning that you should only deploy stable builds. So if your deployment script just takes the latest version from Git, it's wrong. It should double check with the build server. And also we integrated GitHub with more things like Graylog alerts. We don't have to eyeball Graylog anymore, because when it starts raining errors, Hubot tells us about that in our chat. And we also can query Graylog streams right away to see the latest log messages. And we integrated Hubot with GitHub. So whenever someone makes a pull request, it appears in our chat as well. And people who are mentioned can start looking at the pull request a little bit earlier. We also used to have a fire hose of all our commits, but no one could really keep up with that, so we no longer have it. Oh, and one more thing. Hubot can also boost your productivity in many other different ways.
So all these things help us release more often. And when releasing more often, we wanted to be aware of the things that we are actually releasing. So when a deployment is ran, we get a link to a diff that shows us what's the thing that's getting released. And these days, these diffs can be really, really short. But now you're probably thinking, what happens if there's a bigger feature, one that cannot be divided in these smaller chunks, one that has to be released in one that has to be released in one big chunk? So what we do is use feature switches. So let's say I start writing some feature, and it's not finished, but I wrote some important part of it, and I put it behind a feature switch. So it's disabled by default, but anyone in the company can enable it in production or on their development machines and test it. And then we can also enable it for some small percentage of users, say like 5%, and see how it performs. And then we also use A/B testing. So we compare some feature against something else and see which one performs better. Let me give you a recent example. On the left, you can see our old item upload page, and on the right, the new one. And the new one took us to implement like 2 sprints. And we didn't just implement it in 2 sprints and then released it. We released it we deployed it all the time. So first, there were just us looking at it in production. Then at some point, we enabled it for 50% of our users in one country. And we looked at all sorts of data, see how it performed compared to the old one, see not just the whole page, but various parts of it, saw how successful our users were at uploading stuff. And this is a really important page for us. If people would not upload stuff to our site, it would not exist for very long. And I think that's really an ultimate example of deploying something that could have been very fragile, something that could have been written in one big swoop and then deployed after 4 weeks and caused our users a lot of pain. But instead, it was after it was enabled for all of our users, it just worked.
Okay, so now we have instant feedback. Our releases are stable, which is great, but we still cannot go far if we have to stand in line and jump through hoops to make a deployment every time, right? And this is how our deployment used to look like. We had to SSH to a remote server, run a screen with Capistrano and other shell commands, and answer a lot of questions to start a deployment. And then you'd have to wait for 30 minutes. And it's nice to have a break sometimes, but when you deploy more often, this starts killing you. We believe that everything in the world should be as fast as possible, and even faster. So we started measuring our deployment time, because you cannot improve what you cannot measure. And we started measuring how long did each of the steps take, and noticed that there is definitely space for improvement here, since restarting the application just couldn't take 25 minutes, right? It's stupid. So also, since running tests and making a build is also a big part of your deployment chain, we started measuring that as well. And today we try to keep our build at around 3 minutes. And it's a never-ending fight, because like Mindaugas said, we always add tests. And when people add a lot of tests, they tend to slow everything down, and you have to optimize over and over again. And you may ask, how in the world could we get from over 10 minutes with a few tests to 3 minutes, which with more tests than we had back then, like 5 times more tests? And to tell you the truth, it would be at least 30 minutes now if we would just say, all right, we cannot do anything. We just add tests so they slow down, it's natural. But instead we accepted the challenge and took hard steps to get our builds in shape with a little help of steroids. First, we extracted slow things like code coverage and static code checks into a separate build. And it runs just a few times a day, but it keeps our master build lean as possible. And it shaved a couple of minutes right away. Next, we started running tests concurrently by splitting them into multiple chunks and processing each chunk in parallel and aggregating the results back. It was pretty difficult to get it right, but the outcome was truly astonishing. And most of our performance that we have today is thanks to parallel testing. And it goes without saying that you should build on very fast hardware. For instance, if you don't use SSD drives yet,
order them today.
Yeah, we have a van parked in the back full of drives. Okay, so you should also stuff your build server with lots of RAM and have a fast CPU with lots of cores so you can parallelize. There are some other cheap tricks. For instance, since we use Ruby on Rails, tuning the garbage collector and switching to Ruby 2 shaved off an extra minute. So we covered the speed up of the build, and now let's get back to fixing that long deployments. We learned that using better tools always helps, and you should never hesitate to switch to using better tools. The best example is a switch from Thim to Unicorn app server, which gave us 10 times faster deployments instantly. It's because how Unicorn works. When you reload a thin application, it reloads each worker one by one and waiting for a previous one to reload, while Unicorn just starts a new copy with the new code base of your application and then switches it with the old one. And it's really 10 times faster. And it also gives additional feature that you can test and prevent the reload of the application if some tests fail right before the switch. So if something is not caught by our tests and we are deploying a new version and we see that it's going to be wrong, we just don't switch, and then we have the time to fix it slowly and release a new version on top. So our users never notice any breaks. Another thing that was killing us was database migrations. Imagine that you have to alter a table which is hundreds of megabytes. It's nothing, like 1 minute, no one would notice. But what if your database tables are 10 gigabytes, 50 gigabytes, or perhaps hundreds? It's not cool because you would have to wait for 5 hours and the tables would be locked. So your users wouldn't be able to enter anything or edit your data or their data. And it would be not fun. So we used to do that at night, but then we thought to look what other companies did, and we found that most of them used online database migrations, which works like that. You just have a copy of your table, run the alter on the copy, and then switch the tables one with another. So switching is always good. And we use Percona toolkit for that, but there are other alternatives. MySQL. Okay, so there are many other things that we enjoy and use every day, and those things keep developers happy and Vinted running. Well, my personal favorite is Redis. So, by using better tools, we've cut down a majority of our deployment time. It's pretty fast, but we thought we could squeeze a couple of more minutes by using our build server, which is very fast with all those SSDs. And we started to get ready to deploy after every commit to master branch. Instead of compiling our Rails assets during each deployment, which we did before, we now just download them and extract them. It's 3 minutes faster again. So while our deployments were becoming very fast, we thought that doing some shell commands is not fun anymore because, well, you have to log in, there are network failures and things like that. And you don't get a history of your deployments. So we started deploying via Jenkins. And it gives really good benefits because we make Jenkins call all those remote commands for us, and it keeps all the history along with console outputs that include GitHub change sets. So we can track down anything that broke at the exact point of time. And we also track the duration. And when it became so simple, we thought, why wouldn't anyone be able to deploy? So we made this simple web app with deploy buttons, so everyone in our company could just click them. But clicking buttons is not cool, yeah? Not cool enough. So we integrated it with Hubot. And now we can just see in the chat room, Hubot deploy US, and United States deployment is on the way. And you can also see when it starts, what the changes are, and when it's finished. Could it be even better?
Yeah, it could. Writing Hubot deploy US in the chat room is all cool, but after a while, it gets a little tedious. So why not deploy automatically? At first, we were a little bit scared of that, but then we tried it and it worked. And since we did all the previously mentioned things, it really didn't cause us any problems. And to summarize, we went from no feedback or slow feedback when our users tell us that something is wrong, or in the worst case scenario, our C-level officer telling us that something is wrong, to us developers knowing that something is wrong almost immediately after deployment. We went from releases that were causing all sorts of issues in production to really reliable releases. And we went from a really cumbersome process to an automatic one. So these days, there's 12 developers in our company, and it didn't take us that much manpower to achieve all that. It's really not some of you might be thinking that you need a ton of developers and a ton of time to get all these things done, but you really don't. We were shipping features all the time also. And here's how scary stories look like today for us. Instead of something big breaking, there's just this small thing breaking. There's inbox is not under HTTPS. That's nothing compared to the whole form being down, right? And instead of it taking hours to fix, it's fixed in 15 minutes. And when I say fixed, I mean it's in production. And the tests are run and everything's fine. And so we're deploying all the time now, like we said, hundreds of times a day. And there's really no reason why it can't someday be thousands of times. And that's our message. Deploy all the time, because why not? And here's us, if you for some reason want to find us on GitHub or Twitter. And here's Winted's office, and Winted is always hiring. And thank you for listening.
Thank you. Do you have questions for Mindaugas or Tomas? Wow.
Deploying automatically, I assume, would require immense trust in your infrastructure and trust in the changes that they didn't break anything, right?
Yes.
Where does that trust come from? Do you have like very massive end-to-end tests that ensure nothing really broke?
Well, it's multiple things, right? So we have all these things that give us feedback, and then we have pull requests and tests. So it's really not just one thing. It's the whole thing. And we were deploying manually, and then we noticed that we're not breaking stuff anymore, and then we just switched to the automatic process. There's no magic recipe, right? You just have to try and improve, and then you notice, okay, we're not breaking stuff anymore, and then you can turn off the automatic mode.
It took some guts, and some of the developers were pretty scared of that at first, but now it's just natural. It's a part of our day.
Another question?
Could you comment on the impact of server load when you implemented statsd with Graphite, or was there no impact?
No impact, because statsd fires events via UDP, which is non-blocking, and I could tell you the throughput. It's like 3,000 or 4,000 messages a second, and it's like nothing compared when it's switched on and off.
Do we have another question? First question from girl.
So I see that you have accomplished 3 major things during the year or 2. I wanted to ask, have you had any project manager to manage these achievements? Or you manage like a self-organized?
No, it was basically developer initiative, all of that, because no manager would ever want anyone to work on deployments and continuous integration while there are features waiting. So okay, it's just goodwill from developers.
So it was a self-organized team,
yeah.
100%?
Yes.
Okay, thank you.
More questions? So, thank you, Mindaugas and Tomas. And I joked, I have 2 gifts for you.
We thought we would have to share.
Thank you.
Thank you.
So now we will have a short break, and we will meet in 5-1 hall for closing keynote. And don't forget, fill 2 feedback forms. Vinted,